So, moving on to math. We've got a whole list of concepts in your packets, right? Things that are developmentally appropriate. You've got your math concepts available in your packet from the bookstore. If you want to pull those out and be looking at them. When we're talking about math, now we're going to use our concepts, or not our concepts, we're going to use our theme, our unit of soccer, to teach math concepts. So we're going to start with a what?
We're going to start with
A strand, sure. So we're going to pick a math strand, and then we're going to choose a concept underneath the strand. And then we need an activity objective, which is going to have an activity objective has the three parts. What are they again?
ABC.
Our ABCs, our audience, behavior, and condition.
Materials.
We'll talk about materials.
Where do we find it in the packet?
That's a good, it's in there somewhere.
You want the
It's
concept?
right there.
It's in the back.
Thought I just.
The concepts is about,
In your small group plans.
it's about 5 pages from the back, 3 pages from the
Right.
back.
So you've got your strand, your concept, your materials, and in science we have research questions, and in math we have, what are they called? Math prompts. So that's kind of what we tell the child or ask the child. So, where do we want to start? What's a concept we want to teach? For math. You can pick any one. What one looks good to you?
I say
The hexagons on the ball?
Yeah.
Okay, so what concept is that? Geometry is the strand. And what concept under that strand?
shapes that.
Two-dimensional geometric shapes.
So we're gonna, 2D geometric shapes have specific names. What does it say?
It just says squares, rectangles, circles, triangles, octagons, and pentagons are specific two-dimensional geometric shapes.
There we go.
It's like 3 from the back.
Oh, okay.
Okay? And then, do we want to do math prompt or activity objective next? What are they going to do to learn this, or what are we going to ask them?
We're gonna ask
What do
them.
we ask them?
You want to do that first? A lot of times for me with math, I do the concept and then it's helpful for me to write the activity objective and then I go back and figure out what the prompt would be to get them to do that activity objective. I know some people work concept and then math prompt and then activity objective. If that works for you, that's fine. That doesn't tend to be how my brain works best. But if anybody wants to come up with a math prompt first, I'm open to it.
Two-dimensional geometric shapes. Oh, easy. The children will draw circles. Nah, I can't do that. It doesn't, by just doing it, it still doesn't tell what it is.
Why don't we try the activity objective? What do you think the children can do to learn different 2D geometric shapes that has to do with soccer?
The children will examine the hexagons on the soccer ball or count them.
Yeah, that goes in the counting and then changes the strand.
Counting would change the strand and the concept. We could definitely do that. If we did counting, how many did we say? There's 32 hexagons on a ball. So you have to know your kiddos. Could they get to 32?
That one,
Some of them might. might, if they're older 4-year-olds, or older 5-year-olds maybe, if they're really good at counting, we would have to come up with a way. I'm thinking about counting on a roundup. How would I know which ones I counted and which ones I didn't count yet? As we're moving it around, we would have to come up with a way to keep track of that if we had a dry erase marker and
Sticker
mark them off
markers.
somehow. So we'd have to know if they could count that high, and if that would be appropriate for them or not.
What if they count the edges of the?
If they just count the edges of one hexagon, to learn that there are 6 sides, okay?
What are those little things called that you can, oh my gosh, I'm having a brain fart, that you can actually take apart to build a hexagon? Oh my gosh, what are those called?
Tangrams? Tanagrams?
Are the tanagrams?
No.
Tangrams are flat, like little wooden or plastic pieces. They come in hexagon shapes.
Would that take that out of the two-dimensional thing though, if they recreate hexagon shapes using whatever you said?
Or unit block, unit.
The
not unit-
tanagrams are just gonna be, they're gonna be 2-dimensional, so they're just gonna be flat,
Right, and then you can use like 2 of them to put it together to make a hexagon, or you could use 4. What are those
So,
called? I don't know what those.
yeah. So we could put these pieces,
Yeah,
2 of those pieces on top.
Yeah, or then you can do 4 of them to make the hexagons.
Yeah.
Are they
That
unit
was
blocks?
Uh-huh.
Yeah.
Yeah. So if we did that, then are we really talking about hexagons, or are we talking about fractions?
To create hexagons. So if you use that to
So
create
those are great.
hexagons.
So it could go either way.
Yeah.
It could go either way. That would be 2-dimensional. It's related to soccer because there's hexagons on a soccer ball. It's not as directly related, but it is related.
Can they make some with geoboards? And rubber band?
Make hexagons with geoboards.
I mean, if it was. You don't want to convince.
Maybe. Rochelle, you were thinking? Never mind.
Could they count the black ones and then count the white ones? So it wouldn't be as high as 32? Then
Yeah.
they'd have to add them.
So if we come back over here, we'll examine the hexagons on the soccer ball. Is that what would work?
Different color hexagons.
If they just examine them,
They're not doing it.
And they're not doing
then
that.
that's not quite motoric
I
enough.
think they should count them.
So what are we gonna have them do?
Like
Sorting
different color hexagons?
Sorting different hexagons.
Or trace it with their finger? Trace the shape with their finger?
Sorting different sizes of balls.
Yes, better maybe just measure these different sizes of balls.
That's a good
Not
one.
different,
For that change.
So you wanna change the concept?
it will be a, yeah.
No, leave it,
Let's look for.
leave the shapes, because it's geometry you're doing, right? And geometry deals with shapes. The channel will segregate, the different shapes in the block area.
What does that have to do with soccer?
Yeah.
So remember, we wanna connect this to soccer if we can. And I think there's plenty of things in soccer that we could easily relate to math. So just taking some blocks and sorting, great activity to do during free play, absolutely. But what could we have out math-wise on our science display that allows them to interact with soccer and math at the same time?
I think they can count it, they can count the shapes on the wall.
They can count, so you're thinking of going up to 32? If there's 32 hexagons on a ball, you think most of your kiddos will be able to get to 32?
Not 3 and 4.
Four?
Probably not.
Not a four.
Probably not. They're not gonna be able to get that high.
We're gonna need some help on this one.
Yeah.
What if the ball is small? Is it still 32?
Yeah, if it's a different size ball, is it smaller?
It's smaller.
Or the hexagons get smaller.
Get smaller, yeah.
Hexagon.
Yeah, I don't
Some of
know.
them, not all of them, because my daughter had one small and they're pretty big.
So we might have to do some exploration and find a soccer ball that has, what do you think would be a good expectation for being able to count up to?
15.
Maybe 50.
15.
So if we could find a soccer ball that had 15 or less, because we can scaffold with them, right?
Yeah.
And if they're doing it with a more knowledgeable other, if there's at least one kiddo in the small group, or, you know, during free play when they come up to the science center and you as the teacher are the more knowledgeable other and can help them out if they start stumbling over numbers, and giving them a method to mark off so they know which ones they counted and which ones they haven't. That's scaffolding, right? So if we have 15, the children will do what? We'll count
And mark off.
and mark off
15.
The hexagons of the soccer ball.
Yeah.
the hexagons on a soccer ball.
That would work, because you could actually trace the hexagons on the soccer ball, and then you could use tape to put it on there with the numbers, so they're seeing the numbers as well as the shape.
Oh. Yeah, so if you had hexagons that were the same size,
Size
on
as the
papers
ball.
that were the same size as on the ball,
Yeah,
with
you tape them.
numerals on there, they could just put them on.
Right.
That might be interesting. So now, is our concept still 2D geometric shapes?
No.
Maybe.
Well,
I think
yeah.
it would depend on how you carry out the activity.
Yeah.
Yeah, because if you do it, well, yeah, even with the numbers, it'd still be 2D.
It would be 2D, so if you really focused on, okay, put this, you know, here's one hexagon, here's two hexagons, here's another hexagon shape with 6 sides, here's another hexagon shape. So as you're doing the activity with the child, if you're really focusing on hexagons, this would be your concept. If you're really focusing on, let's count these hexagons, here's 1, here's 2, here's 3,
Then it's number and
that's gonna change to number and operations and rational counting up here, right? Or if you wanna make the little paper hexagons that have the numerals on them, then it might be numerals or symbols that represent a specific quantity.
Yeah.
So just depending on how you carry the same activity, you could be teaching 3 different concepts.
And then
Isn't that amazing? Because that's a way to differentiate curriculum. Maybe you have a kiddo who can easily count to 15. And you're interacting with that child during free play. And so then you really focus on the hexagons or on the numerals. Or you have a kiddo that isn't counting to 15 yet. So you really focus on the numbers. I think those are the best activities when we can think of ways to differentiate it for kids at different levels. Because at free play, you never know who's going to show up to explore your display.
If they can count to 15, couldn't they probably get to 16, and then like 16 would be half of the 32, so they could do the white ones versus the black ones. And
Oh, there you go. So even if you just had, let's just count the white. The white hexagons. Let's just count the black hexagons. Absolutely, good thinking. So what would our math prompt be then? What would you say to them?
Are we gonna cover like how many black hexagons they count, or are we just?
Sure. How many black hexagons are there?
are on the soccer ball.
Yeah, we can even make it better. Are on a soccer ball. Does that work?
But we're counting instead of doing the.
Is it an A? How do you spell hexagon? Is there an I or an A?
Yeah, it's
A. Okay.
Come on, Dr. Kim.
That looks wrong. Are you sure?
Yes, H-E-X-A-G-O-N.
Hexagon. Okay. I will believe you. Hexagon. Are we feeling good about math? You want to do one more?
You said how many black hexagons? Okay, yeah.
Let's try one more. Pick another. Ari, you had one that we were going to switch to earlier. What was it?
Me? Oh, what's my sister?
Was it Francesca?
Oh, To measure these different sizes of
Okay.
the balls.
So what would be the concept? About sizes.
No. Measurement, sorry.
So that would be your strand is measurement, and what's your concept?
Some things can be measured by size, small, medium, large.
Yeah.
That's right.
So if we have some things can be measured by size, what are things over here that come in multiple sizes?
Shoes
Shoes,
or cleats.
cleats.
Cleats
The
come in
balls.
different sizes. What else comes in different sizes?
Balls.
The balls come in different sizes. What else comes in
Tops,
different
the
sizes?
shorts.
Uniforms come in different
The
sizes.
fields?
The fields come in different
That'd
sizes.
be a long time to measure.
It would be, yeah, that might be a little harder to measure. So what do we want to focus in on?
The balls.
You can
The
measure the
balls.
balls.
Okay. The players come in different sizes, yeah. So what's our activity objective gonna be?
The children.
The children
I thought it was a bee.
will measure
With what?
a variety of soccer balls.
Do we want to make it, the children will measure the circumference?
What are they gonna measure what are they gonna measure?
Other soccer balls?
The circumference?
The circumference.
Yeah.
Yes.
So they could seriate by size.
Yeah.
Oh, I guess you could measure it by the soccer balls, yeah.
So we could just compare one to the other and seriate them by size. Would that get it? That they can be measured by size? That there's,
Small, medium, large.
okay? So the children will
Small, medium.
Seriate.
seriate soccer balls by
By small to large.
size, small to large. Does that work?
Yeah.
Okay. If they do that, will they learn that something can be measured by size?
Yeah.
Okay. And what's our prompt going to be?
Do soccer balls come in different sizes?
No. Canyon.
Do soccer balls come in
Yeah.
different sizes?
Can
Or can you separate? Or sort?
it has to be who, what?
When?
Say,
how would we
measure soccer balls?
How could we measure soccer balls?
Yeah, that's good.
You measure them by size.
Because it has to be a who or what.
By size or
Small to large.
So we could ask them the question, how can we measure soccer balls? And then they might come up with a different way.
Yeah.
We could just give them the prompt I was hearing over here. Put the soccer balls in order by size.
That's very direct and they'd understand.
So knowing your kids, especially with younger kids that are less experienced with math, sometimes it helps to give them a more direct prompt. Do this. When they have a little bit higher thinking skills, thinking ability around math, when they have some practice measuring by size, then we can start to ask them, well, how could we compare these soccer balls?
So for the prompt, it doesn't always have to be a question, it could be a statement.
Not in math. In math, it could be, that's why it's called a math prompt, not just a math question. So the prompt could be a question, it could be just,
Or
do
statement.
this.
Okay, gotcha, that's what I want.
Yep.
But you said put the soccer balls in order by sizes from smallest to largest. And then you get, oh, do you have to do like the seriation classification on the map too?
Not in math, because we have the strands that we're addressing here.
Yes,
So do we have alignment?
yes, we do.
Is our activity objective, we have ABCs.
Mhm.
The children will is our A, seriate is our B, soccer balls by size, small to large is our C. Is it motoric?
Yes.
I think we're good. Feeling good about math?
Mhm.
There we go.
I love that.
All right.